All right, second half of 9.6. So sometimes we want to switch between polar and rectangular coordinates. The general method is the same as we did in the question in the last video. So given a point in polar coordinates, r theta, just a general point, what are its coordinates using rectangular coordinates? I want you to pause this video, give it a shot, unpause, I'll scroll up, give you a hint, try again, pause, unpause. I think I've got 3 hints for you. First hint is draw a picture. Pause, try to work it out. Write r theta in rectangular coordinates. Your second hint is you're going to need to use some trigonometry. Here's the solution. So given a point in polar coordinates, r theta, we want to find that point in rectangular coordinates. We want to find the xy. So we choose a point on the circle in r theta and draw a triangle. It becomes very apparent using trig that sine theta is equal to y over r and cos theta is equal to x over r. Multiply both sides of both equations by r, and we get y equal to r sine theta, and x is equal to r cos theta. So, in general, if you're given r and theta, that's how you use those two formulas to find the x and y coordinates. So we want to do the other way, too. If we're given the x and y, how can we switch to polar? So go ahead and give it a shot. Take a wild guess. Pause the video, try to work it out. And we've got a couple hints too that I'll scroll down. So pause, work it out, come back, unpause, get a hint, go back and forth. Your first hint is draw a picture. Next hint is that you're going to need to use the Pythagorean theorem. Your third hint is that you're going to need to use a little bit of trig. So here's the solution, how to take rectangular coordinates to polar coordinates. I've got a picture. Actually, that's a terrible picture. Let's get a different picture. So I've got some xy. Draw a picture. R, using the distance formula, is going to be the square root of x squared plus y squared, or the Pythagorean theorem if you use the hint. Root x squared plus y squared, that's going to be my r. And then to find the angle, I know x and y here, x here. This angle is the inverse tangent of y over x. That's going to give you the theta. Be very, very careful about inverse tangents domain when you're using these two formulas to go from rectangular to polar coordinates. Arctan's domain is only in quadrant 1 and quadrant 4. If your point is in quadrant 2 or quadrant 3, you got to use your brain a little bit and not just your calculator. Next, we're going to look at equations of lines in polar coordinates. If our line is through the origin, the equation is theta equals k, where k is some constant. That's going to give you all the points that are at a particular angle at any distance from the origin. It's pretty straightforward. But if our line is not through the origin, the equation of that line in polar coordinates is much more complicated. So the formula is there. Here's a picture. So the equation of a line L in polar coordinates is r cos theta minus alpha equals d, where d is the distance from the origin to the line. Look at the picture where d is. And the point d alpha is the foot of the perpendicular from the origin to the line. This is an instance where a picture is worth 1,000 words, so go ahead and take a second to find d and alpha in your picture. And then the proof is actually very straightforward. It's only 2 lines and you're going to be shocked. So if we consider any point r theta on the line that doesn't go through the origin in polar coordinates, then the cosine of theta minus alpha is d over r. Now it might be useful to pause the video and find those locations in the picture. And then we multiply both sides by r and get the equation of the line. That's the end of section 9.6. The next video will be section 9.